Welcome, welcome. How are you?
Thank you. I'm well. How are you?
Yeah, fine, fine. Trying to make all things running, up and running. There were a little technical issues, but all seems good. And
They're always on.
yeah, since it's online, you know. But tomorrow we will have in-person conference, so we are really excited on that. It will be first, you know.
Yeah, at the same time. Sorry, I couldn't be there. Just getting management approval to flights in this time. It's.
I can totally understand.
Yeah, it's challenging, and spousal approval even harder.
Yeah. Now we are live now, and you can start anytime you want.
Great. So typically I talk and then I leave some time for questions and answers until 3:40, right? So
Yeah.
I'll try to and answer them. Otherwise, I'm all over the place.
The audience asks questions from the question tab, so we will check and forward it from also in chat area. So at the end of the presentation, we can forward it. And
great. So I'll just start and run ahead, and because I can't do both.
Yeah. Sure.
Hello, I'm Shai Almog, as I mentioned before. It's great to be here to talk about debugging in production and developer observability. But first, a few things about me. I was a consultant for over a decade. I worked at Sun, founded a couple of companies, wrote a couple of books. I wrote a lot of open source code and currently work as a developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me. I have a blog that talks about debugging and production issues at talkswithduck.dev. It would be great if you check it out and let me know what you think. I love APMs. They're absolutely wonderful, and I'm old enough to remember a time where they weren't around, and I'm just so happy we moved past that. This image of an APM, it's truly amazing. The dashboards, the details, we're truly at a golden age of monitoring. When I started, we used to monitor a server by kicking it and listening to see if the hard drive was spinning properly. And today, with Kubernetes and large-scale deployments, the level of tools that we need just to get a sense similar to that is insane. Without an APM, well, we're blind, almost blind as a bat, sort of. A lot of the issues we run into start when we notice an anomaly in this dashboard. We see a spike in failures or something that performs a bit too slow. The APM is amazing in showing us these hiccups, but this is where it sort of stops. It can tell us that a web service performed badly or failed. It can't tell us why. It can't point us at a line of code. But I want to step backwards and talk about a different line. This line. On the one side, we have developers, and on the other side, we have ops or DevOps. This is a line we've had for a very long time. It's something we drew out of necessity because when developers were given access to production, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago. Yes, we had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation because the ops guys don't necessarily know how to solve problems made by the developers. They know how to solve ops problems. So when a container has a problem and DevOps doesn't know how to fix it, well, it starts a problematic feedback loop of test, redeploy, rinse, repeat. That isn't ideal. So going back to bats, monitoring tools are kind of like the bat signal. They come up and we, the developer, we're kind of like the bat people, bat person, bat man, bat woman. we need to deal with the villainy of that bug. We're the last line of defense against them. And when there's such a problem, coder bad people need to know where the crime is, where the bugs are happening in the code. So these dashboards, they point us towards the general direction of the crime. They're kind of like a check engine light. They don't tell us where the crime is. They sort of point in the general direction. But here's where the things get hard. We start digging into logs, trying to find the problem. The dashboard sent us over there, and there's maybe a performance problem or an error rate, but now we need to jump into logs and hope that we can find something there that will somehow explain the problem that we're seeing. And that's like going from this jet engine all the way back to Stone Age tools. There are many log processing platforms that do an amazing job at processing these logs and finding the gold within them. But even then, it's a needle in a haystack. That's the good outcome, where a log is already there waiting for us. But obviously, we can't have logging all over the place. Our billing will go through the roof, and our performance will, well, not so much. We're stuck in a loop of add a new log, go through CI/CD, which includes QA cycle and everything. This can take hours at best. Then we produce the issue in production with your fingers crossed and try to analyze what went on. Hopefully you found the issue, because if not, it's effectively rinse, repeat for the whole process. In the meantime, you have a bug in production and developers are wasting their time. I like to call this the CI/CD cycle of death, where your performance dies, where your production has a problem and your customer retention dies, where the cost in terms of hosting dies, and where the cost in terms of the environment is severe because you're wasting so much energy on overlogging, on CI/CD. It's literally killing the environment and your company. It's a terrible, terrible situation. There has to be a better way. It's 2022 and logs are the way we solve bugs in this day and age. Don't get me wrong. I love logs, and today's logs are totally different from what we had even 10 years ago. But you need to know about your problem in advance for a log to work. The problem is I'm not clairvoyant. When I write code, I can't tell what bug or problems the code will have before the code is written. I'm in the same boat as you are. The bug doesn't exist yet. So I'm faced with the dilemma of whether to log something or whether to skip it. This is kind of like the dilemma of writing comments. Does it make the code look noisy and stupid? Or will I find this useful at 2 a.m. when everything isn't working and I want to rip out the few strands of hair I still have left because this damn production issue? Debuggers are amazing. They let us set breakpoints, see callbacks, inspect variables, and so much more. If only we could do the same for production systems. But debuggers aren't designed for this. They're very insecure when debugging remotely. They can block your server while sending debug commands remotely. A small mistake, such as an expensive condition, can literally destroy your server. I might be repeating an urban legend here, but 20 or so years ago, I heard a story about a guy who was debugging a railed system located on a cliff. He stopped at the breakpoint during debugging, and the multi-million-dollar hardware fell into the sea because it didn't receive the stop command. Again, I don't know if it's a true story, but it's plausible. Debuggers weren't really designed for these situations. Worse, debuggers are limited to one server. If you have a cluster with multiple machines, the problem can manifest on one machine always, or might manifest on a random machine. We can't rely on pure luck. If I have multiple servers with multiple languages and platforms crossing from one to the other with a debugger, well, it's possible in theory, but I can't even imagine it in reality. I also want to revisit this slide because I do love APMs, and looking at their dashboard gives me that type of joy we get from seeing the result of my work plotted out as a graph, I feel there should be a German word to describe that sort of enjoyment. But here's the thing, APMs aren't one thing. The more you instrument, the more you have runtime overhead. The more you have runtime overhead, the more hosts you need to handle the same amount of tasks. The more hosts you have, the more problems you have, and they become more complex. I feel this is something that Schrödinger should comment on. By observing, we effectively change the outcome of the application. An APM needs to observe everything. An APM doesn't know what it's looking for. Like I said before, it's a bat signal or a check engine light. It's got sensors all over the place, and it needs to receive information from those sensors. Some sensors have almost no overhead, but some can impact the observed application noticeably. Some people use that as an excuse to avoid APMs, which I feel is like throwing away the baby with the bathwater. We need APMs. We can't manage at scale without them, but we need to tune them, and observing everything isn't an option. Thankfully, pretty much every APM vendor knows that they all let us and they all let us tune the ratio of observability to performance so we can get good results. Unfortunately, that means we get less data. Couple that with the reduction of logs that we need to do for the same reason, and the bad problems we have in production just got a whole lot worse. So let's take the Batman metaphor all the way. We need a team up. We need some help on the servers, especially in clustered polyglot environments where the issue can appear on one server, move to the next, etc. So you remember this slide. We need some way to get through that line, not to remove it. We like that line. We need a way to connect to the server and debug it. Now, I'm a developer, so I try to stay away from management buzzwords, but the word for this is shift left. It essentially means we're letting the developers and QA get back some of the access we used to have into the ops without demolishing the gains we had in security and stability. We love the ops people and we need them. So this is about helping them keep everything running smoothly in production without stepping on their toes or blowing up their deployment. Before we go on, I'd like to explain what's developer observability. Observability is defined as the ability to understand how your system works on the inside without shipping new code. That without shipping new code portion, that was key. But what's developer observability? With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. Developer observability acts very much like a debugger, but it doesn't put our production at risk and works well with production and production scale. So how does that work in practice? Each tool in this field is different. I'll explain the Lightrun architecture since that's what I'm familiar with, and I'll try to qualify where it differs from other tools. In Lightrun, we use a native IDE plugin to VS Code or JetBrains IDEs such as IntelliJ, PyCharm, WebStorm, etc. We can also use a command line tool. Other tools sometimes have a web interface or CLI only. This client lets us interact with the Lightrun server. This hides the actual production environment. Developers don't get access to the production area, which is still the purview of DevOps. The management server sends everything to the agent, which is installed on your production staging server. This is pretty standard for all continuous observability tools. The agent is just a small runtime you add to your production or staging server. It's very low overhead and it implements the debugging logic. Finally, everything is piped through the server back to your IDE directly. So as a developer, you can keep working in the IDE without leaving your comfort zone. Okay, that should raise the vendor alert right there. I heard that bullshit line before, right? APMs have been around forever and have been optimized. How can a new tool category claim to have lower overhead than established and proven solutions? As I said before, APMs look at everything. A developer observability tool is surgical. That means that when an APM raises an interesting issue, we can look at the very specific thing, like a line of code. When a developer observability solution isn't running, its overhead is almost nothing. It literally does nothing other than check whether we need it. It doesn't report anything, and it's practically idle. When we do need it, we need more data than the APM does, but we get it from one specific area of the code. So there's an overhead, but because it only impacts one area of the code, the overhead is tiny. This is the obvious question. What if I look at code that gets invoked a lot? As I said, developer observability gets even more data than an APM does. This can bring down the system, and well, we could end up here. So this is where developer observability tools differ. Some tools provide the ability to throttle expensive operations and only show you some of the information. This isn't a big deal if you don't do anything complex, but if you try to place a breakpoint in a major area, or a snapshot in a major area, you would run into a problem, and then it's a huge deal. And the problem is you can't know in advance sometimes what's a high volume area. I think these things are best shown in a demo because I can talk your ears off, but showing a quick demo can explain this so much faster. I'll use Kotlin for this demo, but this applies to any other language. I'll use Lightrun, which you can download for free and use for free. This isn't even a demo account, it's free, you can use it. And you can also work with other tools because the concepts are very similar for some of the things I'm going to show. But again, I'm going to demo Lightrun because that's what I'm familiar with. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are prime numbers. It sleeps for 10 milliseconds, so it won't completely demolish the CPU. But other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints the results at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting log opens the UI to enter a new log. I can write more than just text in the curly braces. I can include any expression I want, such as the value of the variables that are included in this expression. I can also invoke methods and do all sorts of things. But here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there is a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This means additional logs won't show for a short time since logging exceeded a threshold of CPU usage. This can happen quickly or slowly depending on how you're observing. There's a relatively simple demo to whet your appetite. Let's pull out the big demo guns. So I decided to take on Netflix and build my own movie service. Seems easy enough. Turns out it isn't so much, and those people at Netflix sure know how to build applications. This is rough. I'm terrible at front end. So I hired a developer to build it in React. He also built a Node.js server, which was pretty intuitive for a front-end person. This is actually a pretty sensible architecture. It lets us, the front-end developers, handle all their stuff, including the start of the backend area. Node.js scales reasonably well and can handle stuff it's good at, communicating with the UI, front-end, etc. Node.js also scales reasonably well. So we've got a pretty good deal overall. Storage, transactions, reliability are a decade ahead in the world of Java. So using Spring Boot for the backend heavy lifting also makes sense. I know it and built a lot of stuff with it. This is a merge of the best each world has to offer. It lets us hire the right person for the right job. The problems start when we need to debug this, especially in production. Finding the source of bugs is a process of digging through logs with different conventions and sometimes even different terms for the same thing. And the problem is we have bugs. So here's the app that will take over the world. As you can see, I have a list of movies in the UI that reminds us a bit of those big guys who, again, are doing a pretty spectacular job there. I can add a movie to my list. I can visit my list and see the movies within it. I can also open a specific movie and see details about it. That's pretty much it. Now, but here's the thing. There's still a problem. So let's try to open the James Bond movie. And this is a bit weird. When I click the No Time to Die movie, there's a problem. I see red notice instead. It's a weird bug, and I have no idea why it would happen. I think we can debug it using Lightrun. This time I'll add a snapshot. Some other developer observability tools call this a capture or a non-breaking breakpoint, which to me sounds weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now, let's go back to the browser for a second. And in the browser, we click the movie again to reproduce the issue. And we wait a few seconds for the problem to reproduce. Now we need to go back to the IDE. And now we wait a second and the snapshot is hit. So is this snapshot, what is it? It gives us a stack trace and variables, just like the regular breakpoint we all know and love. But it doesn't stop at that point. So your server won't get stuck waiting for step over. Now, obviously, you can't step over the code. So you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. So what do we see here? We see the ID of the movie, and it seems like the right ID. So this isn't a case of a bad ID passing from the UI. We need to dig deeper into the Spring Boot server. In the Spring Boot server code, we've got the fetch movie details method, which does the actual fetching. I place a snapshot here, and I'll spare you the pain of going to the web every time I have a curl command that performs a request. So I'm running it in a different window here, and it's not really interesting. So now all we need to do is wait for the snapshot to get hit. If this seems to take too long, spoiler, it never gets hit. And the reason for that is the cacheable annotation you see above the method. It seems the response from the model is cached. Unfortunately, we can't rely on guesses. We need to verify. So we need to go to the movie manager, which is our REST controller. It handles all the web requests directly. So here we can add another snapshot again and try to trigger the curl script with the hope that this time we'll get it right and the snapshot will get hit. After a bit of waiting, we finally hit the snapshot in the get method. This means our request is happening, but the failure we're seeing is because the cache gets corrupted with bad data. Why would that happen? And can we continue our investigation? Well, yes, we can. The place where the cache might be corrupted is here in check for file updates. This method runs periodically every 60 seconds and checks the file system for an import file. This is how we add new movies into the system. We place a file with data and it imports it into the database. It might break existing movies. Let's create a snapshot here, and while we wait for a minute for the snapshot to hit, we can use that time productively to delete the no longer used snapshots from before. They will eventually expire, but they're left here in case you need reference. One of the nice things about debugging with snapshots is that normally you don't have to wait. You can just place them all over the code and they get hit at some point. Great, the snapshots got hit just in time, so that means this code is working. Now, all I need to do is evict the cache with a dummy file and we're done. Or are we? Notice the methods here. The batch update evicts the cache, or so it would seem if you're new to Spring. If we'll do that and check for the bug again, we'll see the cache wasn't cleared. The result for this is that Spring only reads the annotations when they're invoked from a different class by default. This is one of those gotchas that often fail developers new to Spring. So in this case, it also happened. This was a relatively simple problem in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here I have a problem with a trending request. One specific user is complaining that the trending list on his machine doesn't match the trending list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are so many users reloading all the time. So a solution is to use conditional snapshots, just like you can with a regular debugger. Notice that you can define a condition for a log and the metrics as well. This is one of the key features of developer observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that's experiencing a problem. Notice I used the fully qualified name of the class, so I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE, as such, it's often a good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with a question mark on it. This indicates that this action has a condition on it. Now it's just a waiting game for the user at this point. This is the point where normally you can just go make yourself a cup of coffee or even just go home and check this out the next day. That's the beauty of this sort of instrumentation. In this case, I won't make you wait long. The snapshot gets hit by the right user despite other users coming in. This specific request is from the right user ID. We can now review the stack information and fix user-specific bugs. The next thing I want to talk about is metrics. APMs give us large-scale performance information, but they don't tell us fine-grained details. Here we can count the number of times a line of code was reached using a counter. We can even use a condition to qualify that. So we can do something like count the number of times a specific user reached that line of code. We also have a method duration metric, a method that also tells us how long a method took to execute. It's kind of like saving the current time millis at the top of the method and then writing it at the bottom of the method minus the current system time milliseconds. It's a very, very valuable metric that I'm sure we all used in that version. This works for production. That lets us narrow down performance impact of a larger method to specific problematic segments. In this case, I'll just use the method duration. Measurements typically have a name under which we can pipe them or log them, so I'll just give this method duration a clear name. In this case, I'm just printing it out to the console, but all of these measurements can be piped to statsd and Prometheus. I'm pretty awful at DevOps, so I really don't want to demo that in this case, but it does work if you know how to do that. As you can see, the duration information is now piped into the logs and provides us some information on the current performance of the method. There's so much more I want to discuss, like tagging and related things. So for instance, every action I discussed so far can be applied to a tag. And as such, it will apply to all the servers in the container and to all the tagged servers. So you can have multiple tags on different servers. So you can have green and blue deployments or Ubuntu servers or things like that, and sort of apply only to a specific tag or to multiple tags. And that way you can get things like metrics for a specific group of servers, or a snapshot for a specific group of servers. When a user hits one server or another, you don't necessarily need to know that in advance. And obviously the advanced dialog has so many things and so many features, and there's PII reduction, which helps deal with privacy issues. And I'll discuss some of these a bit in the final slide. So if I had more time, I'd also talk about things like Airflow and in Python and Spark in Scala or Java, etc. These are amazing cases where developer observability really shines. Workflow, batch processing, streaming, all of these approaches have processes coming up and going down all the time. And these are really hard things to debug. And with tags, they become really, really simple to debug. So this is really valuable for exactly these use cases. So in closing, I'd like to go over what we discussed here and a few things we didn't have time for. So specifically about Lightrun, it supports JVM languages like Java, Kotlin, Scala, etc. It supports Node, both for JavaScript, TypeScript, etc., and Python, and even complex stuff like Airflow, etc. We're adding additional languages like .NET and things like that. So ping me or talk to me if you're interested in something else. Some other developer observability tools have different support for different platforms in some cases. And this is, as I said, a very fast-growing, fast-changing field. So if you're watching this later, or if you'll take time to evaluate, check the current status, because things change overnight in this field. When we add actions, conditions run within a sandbox, so they don't take up the CPU or crash the system. This all happens without networking, so something like a networking hiccup won't crash the server. This isn't true for all developer observability tools. I can tell you it's something that Lightrun has. I'm not sure how many others have it, or if they have it. Security is especially crucial with solutions like this. One of the core concepts is that the server queries information, not the other way around, as you would see with solutions such as JDWP, etc. This means operations are atomic and the server can be hidden behind the firewall, even from the rest of the organization. And this is exceptionally secure and went through quite a few security reviews all the way up to banks and things like that. It's remarkably secure, at least Lightrun is. I can't guarantee about others, obviously. PII reduction lets us define conditions that would obscure patterns in the logs. So if a user could print a credit card number by mistake, you can define a rule that would block that. This way, the bad data won't make it into your logs and won't expose you to liability in laws such as GDPR and things like that. Blacklisting lets us block specific classes, methods, or files. That means you can block developers in your organization from debugging a specific file. This means developers won't be able to put a snapshot or a log in a place where a password might be available to steal user credentials or stuff like that. This is hugely important in large organizations. Besides the sandbox, I'd also like to mention that Lightrun is very efficient, and now benchmarks has almost no runtime impact when it isn't used. It has very small impact even with multiple actions in place. Finally, Lightrun can be used from the cloud or using an on-premise install. It works with any deployment you might have, whether cloud-based, container-based, on-premise, microservice, serverless, etc. Thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions and feel free to write to me. Also, please check out talktodev, where I talk about debugging in depth, and check out lightrun.com, which I think you guys will like a lot. If you have any questions, my email is listed here and I'll be happy to help. And if you have time, I'll be happy to answer them right now and here in the chat, etc. Thank you.
Well, we have one question, Shai.
Yeah.
Question is, how can we integrate it with microservices?
So it depends on the platform, obviously. With Java, integrating with microservices is a bit difficult because the way that we use the Java Agent API and so you need to add Java Agent support. So if you're using something like GraalVM for your microservice, that might be difficult because GraalVM doesn't support the Java agent. But if you don't, then it's just adding the Java agent option in your command line or in the configuration. And there's at the lightrun.com website, you can see the list of all sorts of integrations you can do for practically any application server out there, from Tomcat all the way to Wildfly, Spring, etc., and with all the Kubernetes deployments and everything we listed. And what isn't listed, just use the chat or email us and we'll answer with very specific instructions on integration. There's obviously different instructions for every platform. You just sign up, you go through the wizard, and there's literally how to integrate it step by step, and a chat to help you if you fail with that. Does that answer the question?
I think it's a pretty good answer. We cannot track the follow-up,
Yeah.
but Ahmed can provide some from the questions again. And Ömer also write a comment. Thanks for the excellent presentation.
Thank you.
Yeah, and we have all the questions. If you have questions, we have plenty of minutes.
Mm-hmm. Yeah, great. Then thank you all. I'll be on the Slack as well if people have questions there. And as I said, the slide with all my contact details is there. So debug agent, just my DMs are open. Feel free and write my email, etc. I'm okay with email, unlike some other people. It's fine with me.
Thank you so much.
You're welcome.
Yeah.
Thank you.
We will have a little break, and we will be approximately 15 minutes later here, and enjoy the rest of the conference. Bye bye.
Bye. Have a nice conference.